Hi, good afternoon. Well, thank you very much. This is our last session of this day, a very productive day. It's a pleasure to be here and to discuss three very interesting works, two related to climate change and the last one on shadow banking. Each presentation will be immediately followed by a discussion, and then we will open up for questions from the floor, and then we get back for the presenter, okay? So we will start. The first paper of the session is GDP and Temperature, Evidence on Cross-Country Response Heterogeneity, and will be presented by Chadwick Kurtz. Chadwick is a macroeconomic and an associate professor in the economics department of University of Richmond and holds a PhD in economics from the University of Notre Dame. Chad, thank you very much. The floor is yours.
Thank you. Isabella, thank you for the introduction. I'm presenting today some joint work with Kim Berg from Miami University and Nelson Mark at Notre Dame. And just to kind of show you where this paper fits in, this is going to be an empirical work. And this relates to the economics of climate change. And so if we think about integrated assessment models, these are going to be growth models with this climate module. So it kind of relates production to greenhouse gas emissions to climate change, and then climate change to economic losses. And the first channel here is relatively well understood, kind of how production leads to greenhouse gases. We're learning more about how greenhouse gases lead to climate change. And what we're going to be looking at is empirically more of this channel right here, kind of how climate change, there we go, leads to economic losses. And in these integrated assessment models, these are going to be, there's a function here, kind of this damage function that relates economic losses from climate change. And we're going to be looking specifically at the temperature component of this. And now these damage functions, kind of how this relation between climate change and economic losses, how they're related, in part, they're informed by kind of these empirical observations. And that's where we're going to come in, is we want to look at some of these economic effects using these observational data just to kind of help inform these. And this is kind of our relationship to the literature. And so what we're going to do is we do three main things, which I'll get to in a second. Kind of the evidence of this is what we want to look at is we want to revisit some of this empirical literature. And a lot of this literature, it's a large literature, in the last 15 years especially, that uses Panning regressions of country GDP growth on temperature. So that's what we want to look at. And if you could broadly summarize the literature, you'd see that on average, an increase of temperature leads to kind of like this decrease in GDP or growth, however you want to think about it. And if not exactly that, an increase of GDP will lead to, at least for the poorer countries, it seems to be kind of something that pops out that this is going to be a decrease in GDP or growth for poorer countries. So this is what we're going to do. We do three things. One thing we know is that panels, especially with time-fixed effects, they're going to impose heterogeneity of the responses across countries. And so we want to explore this heterogeneity. So how does it differ? How do the responses differ across countries? Changes in GDP from temperature. And what we do is we find that there is substantial heterogeneity in the responses to growth from temperature variation. And I'm thinking you could think about it in terms of the magnitudes, but we're also thinking about this. I think today's presentation is going to focus on sign. So we're not just thinking about all negative and what's the distribution. It's going to be negative and positive. There is substantial heterogeneity. And we'll see some patterns that emerge from this. And I think that this might be maybe our main contribution, is that there's not a clean story of you look at temperature variation and then you look at one story of it affects countries all in one way. I think our contribution is that there's not that clean story. There is substantial heterogeneity. Second, we are going to explore the directional effects of direct temperature on growth. And so this differs if you have, say, a panel, especially if you have this common time fixed effects. And so we know that a common time fixed effects, what this does is it takes out the average. And so suppose your left-hand side variable is change in GDP, and then you have a fixed effect and a temperature on your right-hand side. What that time fixed effect does is it averages out the cross-sectional average of temperature. And so you're not looking at the effects of temperature, you're looking at the effects of a country's temperature relative to the cross-sectional average temperature. That is, it takes out the global temperature components. And so if you want to know what are the effects of global climate change, or global temperature change, excuse me, on what are those effects, a time fixed effect is not going to be the way to answer that, because there is no global temperature in that. And so what we're going to do is we're going to put that back in. And so one of our other contributions is we want to look at what are the effects of global temperature change in this context. And then finally, in this, we are going to decompose the country temperature variation into a global, so think of like the global temperature component and the idiosyncratic, this country-specific component. And so we can separately analyze what are the effects of changes in GDP from changes in global temperature and idiosyncratic temperature. And what you'll see is that in many cases, these are going to go the same direction. Maybe they'll both be negative for a country, whether it's idiosyncratic and global. But then we're also going to see in some countries that they go in opposite directions. So they're not responding the same to an idiosyncratic or country-specific relative to a global temperature change. And so here's just the data on what we're looking at. We're looking at real GDP per capita from the World Bank World Development Indicators, and it's spanning 1960 to 2017. And our variable interest is going to be this growth in GDP per capita. Our whole sample is going to be 137 countries, and we're restricting this. It has to be at least 30 consecutive observations for a country to be included in here. And then the temperature variables that we're going to look at is going to be population-weighted temperatures. So this is going to be, we're going to have monthly data that's interpolated across the globe. And so we have temperature at each point on the grid, and we're going to overlay this with population. Then we're going to weight this by population to give more, like, what is the effect of a temperature? It's like where the population is. And so if we're thinking of Brazil, it would be the state of Sao Paulo is going to have a much more weight on what the temperature of Brazil is than the state of Mato Grosso, I think is what we're saying. And so to decompose this temperature into globally and idiosyncratic components, let's just look at an example here. So we're going to look at, let the country temperature be tau of country J at time t. And so we're going to decompose this country level temperature at each time into the common global component. We're going to call this G, and you'll see G in here several times, and an idiosyncratic component. This is going to be the country specific components, unique to that country. It is going to be denoted as I. And so the global temperature is going to be a simple cross-sectional average of temperature across countries. The idiosyncratic, that one's common. The idiosyncratic temperature is what we're going to do is we're going to regress the country's temperature on a constant and the global temperature. And that error term, we're going to call that the idiosyncratic component. If you look here, you could think about regressing tau on a constant and G, and this would be your error term. I'm just showing you this is where it comes from. And this is going to be stationary by construction. Just to look at what the global temperature in this is, we've shown this from 1900 just to see, you can see this long time series here. And, you know, the relative global temperature is stable, and then it kind of shoots up here about 1 degree Celsius here in the later part of the sample. Note that you know, our data starts here in about 1960. So 1960, just kind of right after that, is where we're starting to see trending upwards in global temperatures. The methodology that we're going to be using are local projections. And so I think we've probably seen these a couple times today in various presentations. very common in kind of empirical macro, is going to be looking at local projections. And so this is what we're going to do. We're going to regress the percentage point change in GDP from some time t minus 1 at different horizons for each country. And we're going to regress this on global temperature, idiosyncratic temperature, and some controls. And some of the controls are going to be some lags in GDP growth and lags in temperature. What we're interested here is these beta coefficients, this beta G and the beta I's here. And so you can, in local projections, you can interpret this as the percentage response in changes in GDP from sometime t minus 1 to at each horizon, this is up to 6 horizons, due to a 1 degree Celsius increase in temperature at time t. So you can plot out kind of these impulse responses from these. And one thing I do want to know, just econometrically, if we notice, looking back here, you can see that the global temperature is trending upwards. And so we're kind of relying on a couple different papers in here. There's this paper by Ken West in 1988, and it was extended by Park and Phillips. And what we can show is that the least squares estimators of beta are asymptotically normal if with this trending global temperature and a lag if G is exogenous. So our argument is that the global temperature is exogenous to changes in GDP for a specific country, over 6 horizons. One other thing we do is we're going to call this pseudo panel local projections. So we're not going to combine this into a full panel. They're going to call these pseudo panels. And what we're trying to do is we're trying to increase the estimation precision without distorting the point estimates from our regular local projections. And so this is what we're going to do. We're going to run each local projection for each country. And we're going to do a pairwise comparison between each country and each horizon with every other country and every other horizon for their beta coefficients on beta G and beta I. And we are going to calculate the sum of squared errors, and we're going to sort them, and we're going to sort countries into groups of 5 by countries that have the lowest sum of squared errors. And we're going to group these into multiple, we're going to call these pseudo panels. And we're going to run the same estimation, but this time in these pseudo panels. And the difference here is we're going to constrain within these 5 countries, we're going to constrain these beta coefficients to be equal. We're going to allow these coefficients by country to vary, but the effects of global and the coefficients on global and idiosyncratic temperature, these are going to be restricted to be the same across. And just to show you that the point estimates have very little distortion, I just want to show you a comparison of our local projection estimated coefficients with the pseudo panels. And so if we look at this figure, we can see on the y-axis, this is going to be the local projection estimates. The x-axis is going to be the pseudo panel local projection estimates. And we're going to do this for global temperature and idiosyncratic temperature, and I just plotted out 2 horizons. Let's look at horizon 0 and horizon 5. And that red lines are going to be the 45-degree line. And so if we see the estimations are on that 45-degree line, that means that they're giving the same estimations, and they're pretty close across these. Some of these outliers, fall off here a little bit. The most important thing is that if we look at these, the signs are not switching on these ones. And so even though that you're seeing that the estimates are a little different between some of these, the signs are still the same. It's like maybe the magnitudes are different, but the signs remain the same. So it gives us some confidence in our pseudo panel estimates. So here's going to be the main results that we're going to show today, is that we're going to show the pseudo panel betas, and we're going to show this for global and idiosyncratic temperature. And this is going to show the green is going to be significant positive. The lighter green is going to be positive, just not significant. Significant negative is going to be in red. And then this light red is going to be it's negative, just not significant. And the first thing to note is, let's look at the global up here, is that it's not all one color. You can see this is a little bit more. There's going to be some reds, there are going to be some greens, they're a little bit intermixed. And this is going to be at horizon 0. So this is the contemporaneous response in this case. Some notable countries, you're going to see that it's not just small countries that are showing some large and some negative. These are some major countries, right? You look at the United States, it's going to be significantly red. Mexico, red. Brazil, red. So that's going to be negative. Some of these northern countries, Russia, red. Pakistan is going to be negative. But you also look at some of these other larger countries, and you're going to see that they're showing that there's some positive responses to global temperature change. Look at China and India over here. Other major countries, other large countries, Democratic Republic of Congo. These are big countries. It's a little different when you look at the idiosyncratic down here. There's going to be, I think there's less significance in the idiosyncratic ones than we see for the global ones, but kind of the same idea is that there's going to be mixed these reds and greens, which means there's some substantial heterogeneity, and it's not all concentrated by geography as well. Another thing to note is that if you look at the responses from the different shocks, you have global on the top and the idiosyncratic on the bottom here. Some of these countries are showing opposite responses, whether it's from a global or an idiosyncratic temperature change. Brazil is a key example. See, as it responds to global temperature changes, this looks like it's negative. But from the country specific, this is one that's going to be common to Brazil and not to the world. That's going to be positive. And we can see some other countries. Look at Pakistan, India. I'm going to move on to Horizon 5, and there's some interesting things that point out here as well. And so if you look at Horizon 5, this is going to be the last horizon that we're looking at. Notice kind of the richer countries. Think of like the G7. If you notice, if you can spot out countries in the G7, 6 of the G7 countries are significantly negative, and Canada is the only exception, which is negative. It's just not significant. If you look at kind of the rest of the richest countries, we would classify as, it's kind of a mixed bag for the rest of the world. But some of the countries that you think of, the poorest countries in the world, a lot of these are in sub-Saharan Africa. You're seeing a lot of these to global temperature change. They're actually seeing something positive to this, which I think is pretty interesting. And these are some major countries. If you look at India, Nigeria, this is going to be something positive. And there seems to be quite a few countries in sub-Saharan Africa that actually clustered towards this positive response. If you look again, some of these are similar to the horizon 0. Brazil is going to be negative here. If you look down to the idiosyncratic at the next ones here, Brazil is going to be positive. Again, showing these kind of switch signs in here. And so I think the main takeaways here is going to be just looking at this visually, we can see that there's substantial heterogeneity in these responses, for global and idiosyncratic temperature variation. When you start looking at these longer horizons, the richest countries, it seems to be that there's a relationship between the responses of kind of these richest countries, especially if you're looking at Western Europe, Japan, Korea, Australia, the United States, that they're all showing something negative. And then it's a little bit mixed for the rest of the world, and some of the poorest countries are actually showing something positive. And then the last takeaway that just you can kind of visually see is in some cases that these responses are going to be looking the same, whether it's idiosyncratic or it is from a global. Think of like Russia, for example, here, the United Kingdom. These ones are going to be Australia. These are looking in the same direction here. But then there's also going to be examples where the countries are responding differently, whether the temperature change is something that's shared across countries versus whether it's unique to that country or it's not shared. These are examples like such as Brazil. Okay. Just to kind of wrap up, I just want to look at, so what's accounting for kind of this response heterogeneity? I'm just going to show you just some brief results without getting into tables. And so just to kind of understand, like, why are we seeing this heterogeneity and where is it coming from? So what we do here is we're going to regress the estimated coefficients from the local projections on country characteristics, just to see if there is some sort of patterns that we can discern or that pop out of the data, just to kind of give us a way forward to kind of thinking about what explains this heterogeneity, and what explains some of the differences between their responses to global and idiosyncratic temperature shocks. And so we regress the beta coefficients, and this tau is going to be whether it's global or idiosyncratic, and regresses on some of the country characteristics. And we're just thinking of, are they, the higher income countries, how open they are to trade. This is imports and exports as a share of GDP. How important agriculture is. It seems that, in some of the previous literature, that crop exposure and labor exposure to agriculture is very weather dependent, might be temperature dependent. Democracy from the World Bank Democracy Index, just to see how different political regimes might respond differently to temperature changes. Some education, and then latitude, it's more of a control than anything. And just to give you a quick summary of what we find, we look at this for each horizon, but this is just, broadly speaking, this is what we find. And a lot of these happen at, after horizon 2 and past. But we see, and I missed one right here, is going to be log GDP per capita. This is going to be the negative one. And then we can kind of see that from the graphs. We can see a lot of the richer countries were, having these negative coefficients. And so that was kind of visually apparent. We could kind of see that one. But there's also some other ones. It seems that openness, this is the response to a global shock. You can think of openness as going to be positive. It seems that a country that's more exposed to, in this measure, exposure to other countries are responding more positively to temperature variation, at the global temperature variation. We didn't see anything with agriculture. Democracy was negative, and then education was positive in this case. It seems that more educated, global temperature, they respond more positively to global temperature change than kind of these less, than countries that had less high school education. And we did this for idiosyncratic as well, and we find a lot less for idiosyncratic. It's hard to figure out what is at least correlated with some of these responses. And so just to kind of conclude at the end here is, this paper, what we're doing is we're just re-looking at this relationship between temperature variation and GDP growth. We're kind of looking at this, at the country-specific perspective, this time series at the country-specific level. And one thing we note is that there is large heterogeneity in growth responses to temperature variation. I think this is going to be our main point here. And I do put this asterisk here is because what we're looking at is the relationship to the global, or to the historical record. Okay, we're not projecting, we're not saying this is going to be in the future. I think from the talk yesterday, there was mention of like global tipping points and things, and we have nothing to say about what's moving forward. We're just saying in the historical record, what we've seen so far, it seems that it doesn't seem to be this clean story of it's all negative, it's actually the distribution. And then in many cases, there's similarities between how a country responds to idiosyncratic and global temperature, but there's also some important differences as well. Some countries and some major countries, like Brazil, for example, seem to be responding differently, whether it's from a global or an idiosyncratic temperature change. Thanks.
Thank you. So, Chad, very interesting paper to read. Let me jump right ahead to my discussion. So, I am very blind this week, so let me turn this way. So, in this paper, just to summarize what Chad said, there are two questions that they want to answer. No? So, the first one is, how does temperature impacts GDP? And which countries are affected and how, no? Our countries are affected differently. And the second one is, what determines the differential impact of temperature on countries' GDP? And to answer these questions, the paper relies on two empirical approaches. On the first one, or to answer the first question, the impact of the temperature on GDP, they use local projections to estimate impulse responses of GDP growth on temperature. And on the second, the paper regressed the betas of these impulse responses on various countries' characteristics to see which characteristics are driving the greater impact on this on the GDP. So this question that Chad and his co-authors are answering, so let me just say, what do we know on the relationship of GDP growth and temperature? And as Chad said, there's like a vast amount of literature on the topic. So it is well documented that there is a negative relationship between GDP and temperature overall. And just as an example, in 2000, in the year 2000, a 1 centigrade rise in temperature is associated with a decline in per capita income of 8.5%. However, what we don't know is, okay, so what is the causality? How to attribute causality, right? Here, does climate affect economic activity? Or the relationship of climate and economic activity is driven by countries' omitted variables, right? This is the challenge empirically to tackle. And usually, papers, how has the current literature deal with this challenge is, as Chad said, by relying on panel data that exploits time variation in temperature within a country. By doing that, what they do is that they have these country fixed effects that they get rid of the characteristics, cultural characteristics of a country or specific characteristics inherent to a country, and they just, these papers look at variation over time of temperature. And this literature has actually found and has been successful at attributing causality and showing that rising temperatures indeed lead to negative impact to the GDP. So basically, just citing two studies, the first one shows that higher local temperatures, so more looking at subnational temperatures, local higher temperatures within a country lead to lower economic activity. And then also another paper shows robust evidence on how yearly temperature increases reduce economic growth in poor countries. So that has been kind of established very solidly. And other studies have found similar links. No, GDP temperatures are harmful for GDP, especially for poor income countries. That's what the evidence suggests so far. So findings of this paper. So this paper finds that global temperature negatively affects rich countries at longer horizons, right? The effect is larger for richer countries, which is a bit in contrast with what other studies have been finding. And in contrast, for some of the findings suggest that poor countries might be positively impacted by rising temperatures. So again, this positive effect of temperature shocks appears to be more common for poor countries and for countries with slower growth, less education, less trade openness, and more authoritarian regimes. So clearly, some of these findings are going to be in contrast with the existing literature, which is pretty interesting. And so how is this paper then different from these other studies? So first, this paper examines the effect of both local and global temperature. As Chad said, most research so far has focused on only movements in local temperature. So this is a really nice contribution of this paper. And the second contribution is more on the approach, empirical approach to analyze this question. So this paper does not rely on panel regressions. And as they say, there are some issues when including time fixed effects when you use variation across countries. So the first issue is that changes in global temperatures are going to be absorbed by this time fixed effect. And the second is that if you impose a time fixed effect, you are going to be asking or requesting, imposing a lot of homogeneity restrictions to the data, no, across countries. However, it is unclear that this argument, or I think this argument might not be very strong. Our findings in other papers driven by the inclusion of time fixed effects, is it the reason for why these papers find that poor countries are affected the most? And it is unclear that this is the case. So in the papers that I reviewed that are in the literature review, Not all of these papers, the papers that I was citing, one of them does not include time fixed effects, so the results are not driven by these time fixed effects, and they still find that poorer countries are affected the most. And then there are other papers that do include time fixed effects, but then they make more flexible assumptions, no? So they include region time fixed effects, or they include poor country time fixed effects to kind of relax this restriction. And what they say, they show is that this time, like however you enter this time fixed effect, the results do not change. So one suggestion here for the authors is to do more work to understand then what is driving the differences of this methodology with the other methodologies that rely on panel data. Okay. So I think so where this paper strikes me as clearly making a contribution is on the role of global temperature, which other studies really don't do, or of what I read. But I think that the contribution in the paper could be made much stronger, because I think there's a lot of information there that you're not exploiting yet. So for instance, why not explore in more detail the spillover effects of climate change? It's really interesting in the figures that that Chad showed, that you see, for instance, Brazil having a positive effect on the idiosyncratic temperature, but a negative effect on the global temperature. In the paper, it is very quickly, you just say, well, this might be because spillovers, no? Like Brazil trading partners might be, heated differently, but that's it. I think in one sentence you say that, and I was like, oh, this is pretty interesting. I haven't seen this like this spillover of climate change. And I think you could actually, like flesh it more, do more work to really show this. I'm gonna share more ideas on this. So again, cool idea of paper, global temperature captures external spillovers via trade, via financial linkages, but I don't think you're really, I think you can do more to show us this. If you think that one mechanism why that global temperature is affecting different countries, you could, for instance, instead of doing the global average, cross-country average of temperature, then do for Brazil the average temperature of its main trading partners. Is it the average temperature of its trading partners the reason why Brazil is going to be more or less affected? Do the neighbors of the region, like try to go further with this measure of global temperature to try to understand why global temperature affects differently a country's GDP to the idiosyncratic temperature. I think doing so, this exercise, in my opinion, very humble opinion, could differentiate a lot your paper from all this other work that there's a lot of work on this, so it's going to be important that you differentiate very well from the existing literature. And then other minor comments, no? So in this figure that there's in the paper, the estimated magnitudes appear to be a bit high, but I don't know if it's a typo or they are not expressed really like how to interpret. So it's a paper. We know that some of the responses are quite large in magnitude because the responses are stated in percentage and are for 1 centigrade increase in temperature. And you don't see perhaps, but the responses seem to vary to 10, 5, 20, so like 10%, I'm assuming. But then when you compare them to the other papers, they don't seem too high, no? Like in the other papers, they also say, well, a 1 centigrade rise is associated with a 1.2, 1.9% decline in income. So it would be nice. So now it seems that your results are much more higher, even when you consider the movement in 1 degree centigrade. So is there a reason for why? Is there any omitted variables, perhaps? I don't know. This is something that would be nice to have more information on. And then also, I would push you a bit on the interpretation of your findings, no? So in the paper, it is reported, or the paper reports different effects, but where I missed a lot is on the interpretation. How should I go and sleep peacefully when I see Mexico isn't red in all your maps? No, but what I meant is, and it's true, Mexico does really a bad job in all the maps in the paper. But what I meant is, for instance, Brazil's case, no? So it seems to have a positive impact from higher idiosyncratic temperatures, but a negative on global temperatures. Why? Like in that, there is zero information on the paper. No, it would be nice to flesh out what is happening, what do you think is driving it, to do some tests like perhaps the ones I suggest for Russia. You see a positive impact from higher idiosyncratic temperatures in the short term, but a negative in the long term. Why? What do you think? Like, is there a way for you to get a sense of what might be driving that countries are responding in opposite, magnitudes in the short and long term? And then, so just to end, I would then push you to provide more economic intuition behind these results, better connect these findings to the storyline of the paper, and to see if the results are consistent with the adaptation hypothesis, or to what extent, no? Like, are countries in the long term adapting better to this climate change? And just to finish, because I ran out of time, Chad, the paper is really nice. It's thought-provoking. It's very well written. It's very interesting. The analysis is very rigorous, and I think it is very policy relevant. And I think these minor comments might help push this paper better. But thank you. I enjoyed a lot reading the paper.
Thank you very much, both of you, Chad and Claudia. I would open up for questions from the audience before coming back to Chad. Marco.
Hi, Chad. I have a question about when you talk about the weighted average to construct the temperature for the country. You use the population, where population is located, correct? Mm-hmm. To do that. I'm wondering if not better to use the location where production are located, because sometimes we don't have the same location. For example, in Brazil, we have agriculture. Mm-hmm. It's very far from the big centers, and also, for example, hydroelectric production, that is important. For example, in 2021, we had a problem with droughts, and this affected energy production. So it was a very hard shock. And then the dams are far from the population, and maybe it's something that could affect your results. Mm-hmm. I don't know. The other point is what's behind this positive idiosyncratic response to temperature for Brazil, for example. Maybe, again, agriculture, sometimes higher temperature could increase production. If you are talking about a big country, different temperatures in different regions. In the south is cold. Then if you have higher temperature there, maybe production can increase. Then only these two questions. Thank you.
Any other question?
Hi, thank you. Considering that investment needed for the climate change and to tackle this issue, do you think that could the higher growth of the poorest countries found in your study, this could be explained by the investment commitment of the richest countries at the time of Paris Agreement? Thank you.
Is this okay? Yeah, I'll start with your question. This is the most recent. Yeah, I'm not sure about that because our sample starts in 1960, and so I just wonder how much that would, how much that investment spilling over from the rich world to the developing world is present in the entire sample. I'm not sure about that. I don't have a good handle on how much was actually added in investment through this channel. I'm not really sure, like, as a share of like GDP, like how important it is. I guess I don't have a good handle on that, but that's something I should really look into. Well, thanks for the comment. And then I'll respond to your comment about first the weighted. That's a great suggestion about where is the production coming from, because you're exactly right. That's what matters. And so we actually kind of thought about that. And Brazil is a great. We were thinking of Canada was the one we were thinking of. Energy it's out in the middle of nowhere, so it seems like a lot of production's out not near where the population is. And so is it representation of where the population is? And I think ideally that's what we would like to do, is where the production located. I think that finding that data, especially in kind of a finer grid, is going to be a little harder, I think, in terms of in putting that in practice. But I think that if we could find something like that, that would be the optimal. I think that would be our optimal weighting measure. And thank you for your comments. Just a few things, just so we can move on. That's a great suggestion. I think thinking about the exposure. So we're looking at global temperature, but thinking of the exposure to your trading partners or your nearest neighbors, and that might be the most relevant global. Is it really global, or is it who the relevant trading partners or who you're in contact with? That might actually be what's most relevant, rather than just global. Does it matter? The temperature is globally changing in a place that you have no contact with? Probably not. That's something we're going to have to do. In terms of, there's several comments we'll have to talk afterwards a little bit. But one more thing about sizes. I think some of the sizes do get bigger. I think some of the results, these are compounded. So these are impulse responses. And so this would be the change over 6 years. And so I think some of those other ones where it's like 1 to 2%, that's like a 1 year change. And so this would just be like, what is the cumulative over those 6 periods? And so there's something to look at. We definitely have some outliers in there. And I guess when you have a lot of countries and you have these samples, there's going to be a lot of outliers in there. And we do have some of those, and some of those are implausibly larger, implausibly small. And we do acknowledge that part. But I think for a lot of them, it's the timing issue is for some of them. Mm-hmm. All right, thank you.
Thank you very much. So let's move on for the next paper. The title of the next paper is Global Bank Lending Under Climate Policy. Claudia will present it. Claudia is an economist in the finance and private sector development team at the World Bank. Her research has focused on understanding the impact that access to finance has on individuals and firms, and the role that financial services have in promoting economic development. She holds a PhD in economics from UCLA. Thank you, Claudia.
Thank you so much. So thank you for staying to this presentation. So the title of my paper is Global Bank Lending Under Climate Policy, co-authored with Ashley Demirgut-Kunt, my colleague Álvaro Pedraza at the World Bank, and Freddy Pulga from Universidad de La Sabana. So to jump to the motivation, climate policy is aiming to reduce carbon emissions by doing basically 2 actions. The first action is to promote renewable energies and increase energy efficiency across sectors. And the second action is to impose restrictions on activities or sectors that contribute to GHG emissions. And it's something that the literature researchers now and policymakers are trying to understand is what role banks play here. And this is a very important question because banks are the main financiers of firms worldwide. So what are banks doing when climate policies are enacted? On one hand, if there is regulatory arbitrage, we might think that banks may undermine efforts to combat climate change. Why? Because banks may move capital away from countries that are strengthening regulation and into countries that have lax regulation. However, if banks have a preference for green assets, then banks may be financing innovation, may finance greener activities, and may expand lending in countries that are strengthening implementing climate policies. So the role that banks play is unclear, and this is what we're gonna try to empirically answer. So in this paper, we're going to start focusing, our main focus are gonna be global banks, which channel a large fraction of all the lending worldwide. And we're going to examine how the lending of global banks response to changes in the climate policy of a country. To identify the response, we're going to have two empirical approaches. So we're going to first compare the credit growth of global and domestic banks that operate in a same country after a country or once a country is strengthening or in a country that is strengthening its climate policy. So there the variation is looking at the same country but comparing global and domestic banks. And then we're going to say, okay, let's do a different exercise, and we're just going to focus on global banks at a given year. And we're going to say what is happening, to analyze what is happening to the lending of these banks across their subsidiaries in different countries. So in this exercise, think of Santander. Santander in a given year is operating in Brazil, in Mexico, in what so on. And we're going to try to say, okay, so if Mexico is strengthening its climate policy, how is the lending of Santander Mexico doing compared to the other subsidiaries? So these are the two empirical approaches that we're going to use. And then another layer of this analysis is that we want to differentiate global banks by their preference for green assets. And this is based on literature that has been showing that there are some banks that are making these green commitments. So far, we are proxying these preferences for green assets with the environmental scores of banks, but we're trying to get at other proxies that might be better. So to summarize the findings, think of the way we're thinking is classify or let's group banks in 4 groups. No? So we have green global banks, we have brown global banks with low environmental scores, we have green domestic banks and brown domestic banks. So what we're finding is that when a country is strengthens its climate policy, the credit growth of green global banks in this country is going up. However, for the other banks, we're not detecting any significant change. So basically, our message is that there seems to be a lot of heterogeneity in the cross-section of banks. A 1 standard deviation increase in the index of climate policy of a country is associated with an increasing credit growth by green global banks of 5.2%. However, we also find that brown global banks do not exit these countries that are implementing climate policies. And on domestic banks, we don't find an effect, but mainly because we're looking at the extensive margin. We don't see if domestic banks may be expanding their lending to certain sectors within, the intensive margin we're not going to capture in this research. But interestingly, and this is new exercises that we're running these weeks, so we're finding that there seems to be some spillovers effects. And what we mean by this is that when other countries, global banks that operate in many countries, when one subsidiary is in a country that strengthens its climate policy, brown banks expand in countries that are not expanding their climate policy. No? So we call this the spillover effects. Brown global banks appear to expand their operations in countries with relatively weaker climate policies. So where this paper fits in the literature, this literature is pretty scant, but it's growing very fast. And there is some evidence that after the Paris Agreement, banks reallocate their lending away from polluting firms. There is also some evidence, actually in Brazil, it's work that I've been doing with other 2 co-authors. We find that in Brazil, banks respond to higher capital requirements by lending or shifting away their supply of credit away from firms that are more exposed to climate change. So basically, there is evidence on this, but we still don't know much about it. No? So this is where our paper is going to make a contribution. So to jump on the data, our information for climate policy is going to be coming from the German Watch Institute. This institute collects or compiles information across countries and generates this climate change performance index. This information is collected at an annual basis. And basically, they rate the climate protection performance of countries. And mainly, they focus on 4 components. The first one is climate mitigation. The second one is energy use. The third one is renewable energy use. And the fourth is climate policy. So for us, we're going to be focusing on climate policy. What is the climate policy measure that German Watch produces? So this measure, what they do is they send surveys to energy policy experts all around the world that have to fill out the survey with their perceptions about countries' climate change actions. So for every country, we observe 4 energy, this index basically captures the perceptions of 4 energy experts on how this country is implementing new climate policies, and not only designing new climate policies, but also they say, okay, how are the old policies being implemented? No, so this is the way German Watch measures this strengthening of the climate policies in a country. Importantly, we have considerable variation of this index, both across countries and over time. The index is collected for 58 countries. It started being collected in 2007. Our data on banks, we're going to combine this climate policy measure with data on banks. It's coming from the Fitch financial statements from Fitch Fundamentals, typical balance sheet information of all banks. And we see also some information on the employment of these banks and on their profits. And then to identify in this data set which banks are global, we're going to manually merge our data set with a fact set. So FactSet gives us the geographic revenue of all institutions across different countries. So with this data set, we're going to find 204 global banks that derive at least 1% of their total revenue from their international operations. So for instance, in this data set, we observe, you'll see in the next slide, Santander, and then we see where Santander operates in the different countries. We're also going to have data on the environmental scores of banks that is coming from Refinitiv. But what we're doing, given that these environmental scores, we're not sure if they capture a green preference or if they are only noise, we're going to start running more analysis with other information on the green preferences of banks. So we have also which of these banks are signatories of the Task Force on Climate-Related Financial Disclosures. If you're not familiar with this is a framework that companies voluntarily join this framework to disclose their climate-related information on their financial filings. So from our data set, we observed 83 banks that have signed this framework, and we're going to use this variation, whether you signed or you did not, and when did you sign? Did you sign at the beginning of the task force, or you are one of the late signers? So as I was saying, this is how we are identifying a global bank. My example here is Santander. We see in the Fitch data set, from your revenue, we see how much of the revenue of Santander is derived in the different countries. But then for each country, we know the balance sheet of Santander Brazil, Santander United States. So we know how much lending is happening in each country. And we also know what is the environmental score of the global bank Santander, and we attribute this environmental score to all the subsidiaries of Santander. So just to show you that we believe that our measure of environmental scores is not noise, no? So here, what do we see? First of all, this is actually the first thing that we see is that global banks, if we plot the distribution of the E-scores, we see that global banks tend to have higher E-scores and are more likely also to be signatories of this framework. No? So global banks start signing very early. Domestic banks are the ones that are signing late. Also, if we look at global banks, subsidiaries of global banks, we see that the environmental scores of those banks that are members of this framework, task force, have the environmental scores are higher. So we take this information as showing or suggesting that these environmental scores are not noise. They are telling us something about the preference for green assets by banks. So jumping to my methodology, we're going to first compare global and domestic banks in a country. And to do this, we're going to run these regressions. This is the estimating equation. And importantly, so CPM is the climate policy measure. We're going to interact this climate policy measure with an indicator variable that flags which of these, if the subsidiary of this country is part of a global group, or zero if it's a domestic bank. And then we're going to saturate this specification with a bunch of information of the subsidiary that may be related to the credit growth. And importantly, we're going to include also country times year fixed effects to isolate variation that may be driving variation in the credit growth in a particular country. Importantly, as I said, we're going to also interact the e-scores of banks to get at the heterogeneity of not only global banks, but global green banks. So the first thing that I wanted to show you, when we only run this very simple regression with the cross-section of banks, the first thing that we note is that nothing is significant. Like the bank lending, the credit growth of a bank is not responding to the climate policy measure of a country. So this coefficient would report that there's a 1.16 increase in credit growth, but it is not significant. We also don't see that global banks are differentially increasing or decreasing their lending. And then when we began to explore the heterogeneity by preferences for green assets, we do find that global banks that have higher environmental scores are significantly increasing relative to other banks their credit growth in a given country. So this means that when CPM or the climate policy measure goes up, is higher, global banks with higher scores expand credit relatively more. So now we want to know, okay, so what does that mean? What is in absolute terms the credit growth of these global banks? So to do this, we have to sum up a bunch of these coefficients. And here I'm going to summarize you how the response of global banks seems to be. So in the x-axis, you can see the environmental scores of banks, and in the y-axis is the credit growth. So clearly what you can see is that the trend is positive. And what this means, and this red line, solid line, is the median environmental scores of a global bank. So global banks above the median significantly expand their lending in absolute terms in countries with stronger climate actions. And this effect, starting from the median, is statistically significant. So, okay, so this is our first evidence that global banks appear to expand their lending in countries with higher climate actions if they have green preferences. The second exercise is then to only focus at global banks and see how they are lending in their subsidiaries when the climate policy of one of their subsidiaries is changing. So key to this specification is the inclusion of bank year fixed effects. So we hold constant everything except isolate all the variation and only focus on variation within a bank year across its subsidiaries. And here, again, with this very different exercise, we again find that green banks or global banks that have higher environmental scores are entering more aggressive in countries that have higher climate policy measures. So this coefficient implies that when a country's climate policy measure increases in one standard deviation, a global bank with environmental scores in the 75th percentile is going to expand its lending by 2% in that country. And we corroborate that this effect is not only coming from the credit growth of this bank, but also the employment growth in its subsidiaries in countries that are implementing these policy actions. So very quickly, just to talk about how we're measuring these spillover effects. So what we're going to do is introduce this WCPM. So this is the weighted average of the climate policy measures of other subsidiaries. So what is happening if my other subsidiaries improve? How is my lending in the country that is not in these other subsidiaries being affected? And here what we find is that it is the global banks that have low environmental scores. So this is the 25th percentile distribution of E-scores. So only those that lie below this 25th percentile are those that statistically significantly, they are moving into countries that when other subsidiaries are implementing climate policies. So countries, they move into countries with weaker climate policies. So we are also able to rule out several potential concerns. One is, well, how can we tell if the E-score is a good proxy for banks' green preferences? We think our results suggest so. So first we see that banks that are headquartered in countries that have high GHG emissions have lower environmental scores, and this relation is very strong in the data. We also see that our results are robust to alternative definition of green banks. If we use if we use whether the bank is incorporated to this task force for related climate, reporting their climate exposures, our results remain very similar. We also, one other concern is that climate policies might signal an improvement in the institutional framework of a country. So it has nothing to do with the climate, it has to do with we are going to do better regulations and we're strengthening our policy framework. However, we also rule this out because when we, instead of using the E score of a bank, we use the G scores, the governance scores, we do a horse race and we find that governance scores are reporting nothing, are not associated with increased lending when countries improve their climate regulation. We also rule out that our results are coming not from global banks, but from banks that are very big. No, it might be that being a global bank is correlated with other characteristics that may drive banks to signal their green commitments. For instance, banks are very big, the global banks are much bigger, the funding type of these banks is different. So we actually control for non-linearly for many things, for their types of assets, the share of security issuance and asset portfolio, and our results remain robust. And finally, we also see that it is mainly global banks that are headquartered in other countries, those that more easily are more sensitive to the changing climate policies. No? So there's something about being a global foreign bank that makes them more sensitive to exit or entering a country. So just to conclude, this paper highlights a selection mechanism based on banks' green preferences. So banks, global banks appear to be going into countries that with solid, strong climate policy frameworks if these banks have greener preferences for green assets, but on the contrary, brown banks seem to be directing or growing more in countries with weaker climate policy. And finally, government commitments to address climate change can attract foreign banks with strong preferences for green assets. So thank you very much. Looking forward to the discussion.
Thank you for giving me an opportunity to discuss this paper, and thanks, Claudia, for a nice presentation. Let me give you some, oh, I'm sorry, that's right. Okay, let me give you some motivation showing a big picture of this paper. We can think about two opposing channels that the authors identify when we consider more stringent policy that tackle climate changes. And the first one is connected to the shifting production to destinations with less costly regulations. This is called the regulatory arbitrage channel. And the opposing force is that multinationals with more efficient and cleaner technologies may be attracted. And a natural question arises, which effect is bigger? And a big question is, what is the role of banks in transmitting shocks, in transmitting climate policies in this case? And a specific question that the authors ask is how is the lending response of foreign bank subsidiaries affected by domestic policies related to climate change. And the authors collect data on climate policy component, and this constitutes 20% of the CCPI index. Yesterday we discussed the meaning of this index and some potential perils of using this index. And the authors combine it with a data set of Fitch fundamentals and some other data sets. And the empirical strategy is that the authors explore the variation in the lending of foreign banks and domestic banks when climate policies become tighter. And the second exercise is that the authors consider how bank credit is reallocated across the subsidiaries of global banks and subject to climate-related actions of a given country. And in order to deal with the possibility of spurious relationships, the authors include those variables that are correlated with climate policy and bank credit, and they also include country year and bank year fixed effects. Summary of results, the authors find that global banks with higher E-scores increase the lending following an increase in the host country's climate policy index. And it is very interesting that this effect is heterogeneous. So those banks with preferences to greener assets react, while other types of banks are mainly irresponsive. So the main contribution, as I view it, is that the authors empirically evaluate the lending responses of foreign bank subsidiaries to climate policies in the host countries. And I find this paper very interesting and very relevant to policy making. I have a bunch of comments which are mainly about the details that I think worth exploring and worth clarifying. The first one is about the climate policy component, as I mentioned, and this can be rather subjective, right? Because it is based on opinions of experts, and I would like to see some more details about how these experts are chosen, whether they are their identity is changing over time. So do we look at the same experts over time or not? So maybe some robustness exercises when you include other components of the index may help. I completely understand why the authors use this approach here, because they give more variation in this index, but maybe some robustness checks may make sense. The second comment is about the definition of global banks. It is understandable that there is no unique definition of global banks, but here authors define them as those institutions that report at least 1% of their revenue generated in a different country. So the question is, why do they choose this threshold, 1%? And maybe some discussion about how this approach is related to the other literature might be useful. The third comment is about an assumption that all subsidiaries of a global bank are assigned the same score as the parent institution. I see the discussion of your e-scores, and I really like that you address the point that e-scores actually reflect something related to climate policy actions rather than corporate governance. So here, just to give you an analogy, there are the BLS papers about the total factor productivity, and there is evidence that there are different productivities of plants in different cities within one firm. So since you are looking at subsidiaries, right, they have different separate legal structure, so they are more independent compared to branches. So I think maybe some more work and looking at this point in more detail might also help and justify whether you can use this assumption here. The fourth comment is about the distribution of e-scores of global banks. So it is skewed towards higher scores compared to domestic banks. And this is not just a comment, but maybe some point for discussion. Would it somehow indicate that climate policies, in fact, favor global banks because of a channel related to less competition, right? So, in other words, whether we observe the first channel, the regulatory arbitrage channel. And I think what I would like to see maybe some kind of a very simple theoretical model or discussion of theoretical forces, some mechanisms, and this may also help to better justify the results and also relate your empirical evidence to some theory. And the final point is about, I think, endogeneity. It's maybe a general issue that might be present in this kind of empirical exercises. So the idea is that is there reverse causality? In other words, could decisions on climate policy actions be affected by bank lending? That's something maybe you can address with instruments, but I see that you include a bunch of controls in your exercise, but possibly some discussion may be helpful. Okay, thank you.
Thank you very much. Do we have any questions from the floor?
A short question related to last point of the discussant. You mentioned that you, and I think you did it really well, addressing the indigeneity of the climate component, but what about globalness component? To be global is also endogenous to having a large lending net, and also a global bank might just face more scrutiny from the media to be green. So maybe if you can have some measure of globalness and compare global banks to each other. Otherwise, I think very, very good work. Thank you.
Yeah, nice paper. I think besides the climate policy actions of a given country, what's even more important could be uncertainty about the climate policy actions in the short, medium term. So I wonder whether you consider examining the behavior of global banks along some events, like the Trump election, for example, that reduced a lot of the uncertainty about regulation of transition risk, and many papers make use of that event. And this is also related to the last point about endogeneity, because I think this index, as reflected based on surveys of experts, might introduce a lot of endogeneity and also be anticipated by banks, right? So unanticipated event like a Trump election what global banks, how have they reallocated after across the globe after the Trump election, for example?
Okay, just one final question. Okay, go ahead.
Yep, just a couple of questions. I was curious about how these banks are expanding credit. Are they obtaining cheaper funding from green investors? On the liability side, is like you observe an increase in debt or equity, and how persistent these effects are, because I think that these climate policy changes at the country level are kind of persistent, but do brown banks or domestic banks catch up at some point or not?
Claudia, back to you.
Thank you. Let me start with the last to the first question. So on that, we don't know. We haven't. So what we rule out is that it is not deposits. It's not that local subsidiaries of a global bank are increasing their deposits. No, it is coming from our lending. How are they, like, are they bringing lending from other countries? Like, we just know that they are expanding more in these countries. This is something that we can look out in more detail. On the exploiting the uncertainty of climate shocks or climate policies, this is actually something that we plan to do. We haven't done that. We wanted actually to see it when Trump pulled out of the Paris Agreement, for instance. So this is something that we're thinking on exploiting as we in future work. And I agree, it gives you a nice variation that we could exploit and see if global banks do what we say here, no? On the endogeneity of global banks, I think, and it is related to the discussion, I think, yes, like, I think the way I see it is that global banks is, especially if they have like these high environmental scores, they might be very well suited to serve firms in greener industries, because this is why they are having, one interpretation is that this is why they are having these scores, no? They are expertise, they have the expertise on these new industries, so this is good news for them, no? When these climate policies happen, they have the comparative advantage to serve these these sectors that are being, pushed forward. But that is probably how we want to interpret these findings, no? It's like, are banks contracting? No, like, there are banks that are specializing in these sectors, and this is consistent with what we are finding. And on the, like, coming to the discussion, like, on the endogeneity of the measure of climate policies, and if we try to exploit the other components, one problem with the measure, with the German watch, the other components, is that they changed the methodology on all other components except for this one. So I think in 2013, the others are not comparable over time, which is terrible. The only one that remained the same was the policy component, which is why our focus is on this one. However, we also think the other ones are not much on policy experts, but on the outcomes. Is a country using more renewable energy? Is the country using more energy? And this we see more of a problem for endogeneity, because then you might expect that a country that is growing is relying on more energy, and then more bank lending is flowing to this country. So it's less clear. I think the endogeneity concern is even bigger if we were to use those other measures. So on the E-scores, I think you raised a really good point. Like, we are using the E-score of the global bank and attributing to all the subsidiaries. But the reason we do this is because of lack of a better measure. E-scores are only published for public banks. And then I think we don't like, so basically we see the main, global bank, and then this is as best as we can do. On the definition of global banks, it doesn't change much if we increase the threshold to 2%, 3%, 4%. What does change, and what we don't want to lose global banks that are small. So by keeping the threshold really low, we make sure that even if there's a bank that is really big in its country, if it has 1% of operations elsewhere, we want to have it in the data set. No, if not, we risk to only looking at like the super big global banks that are operating in many countries. But I think I understood, I answered all the questions. Thank you so much. It was really, really useful. Thank you.
Thank you very much. So we move to the final presentation for this session. The topic is dynamic bank capital regulation in the presence of shadow banks. And Arseni will present it to us. Arseni is an assistant professor at the Department of Theoretical Economics at HSE University in Moscow and holds a PhD from Georgetown University. Thank you, Arseni.
Thank you very much for including my paper in the program. And this is very different from what you saw in the session. It is a theoretical model, but it has some empirical motivating evidence. My motivation was rooted to the fact that bank regulatory standards were tightened in the aftermath of the global financial crisis, and this has been raising concerns among the policymakers that loans can migrate from now more regulated banks to unregulated shadow banks. And in this paper, I explore how the competitive interactions between these two types of banks affect the design of optimal capital regulation policies. In the framework I have in mind, regulated banks can take on excessive, socially inefficient risk because limited liability and deposit insurance provide incentives of banks to shift from safe to risky assets in their portfolio of loans. And so limited liability shields banks from downside risk, and deposit insurance actually subsidizes risk-taking by decreasing the costs of issuing deposits. And capital requirements can curb these incentives by forcing banks to have more skin in the game, meaning that decreasing the value of limited liability. But this happens at the expense of liquidity provision and some migration of credit from regulated to shadow banks. In particular, I ask the following questions. How should optimal capital requirements change over the business cycle? What are the effects of higher capital requirements related to the allocation of credit across regulated and shadow banks? And how do simple rules, and here I'm analyzing the so-called the Basel rule that responds to capital to credit to GDP ratio, perform relative to the Ramsey optimal rule. And I develop an aggregate macroeconomic model that allows for feedback between macroeconomic developments and risk-taking incentives of banks. And here, risk-taking incentives are endogenous. And in my framework, there is a clear role of capital requirements in dealing with excessive risk-taking incentives. So just to preview my findings, depending on the sources of shocks, the optimal response of capital requirements can be magnified once we take into account the interactions of the two types of banks when we consider a TFP shock, but this can also lead to a change in the direction of the optimal response of capital requirements when we consider capital quality shocks. An interesting result that I find that tight bank capital regulation does not necessarily indicate that there is a intermediation of credit from regulated banks to shadow banks. Concerning the simple rules and the Basel rule, I find that a rule that differentiates between two types of loans outperforms the Basel III rule that only conditions on aggregate loans. And in my framework, actually, the standard Basel III rule does not work well. And then I also study how the performance of this kind of rules can be further improved, and it can be achieved by a small elevated static capital requirement that I'm calling a static buffer. My paper contributes to a literature that looks at the composition of bank credit that affects risk-taking. And this is the literature. The main difference that I'm including explicitly the shadow banking sector in my framework. Other papers take a complementary approach by looking at the volume of credit and the role of the risk of bank runs, the role of leverage in the framework with the shadow banks. How my model is different is that I'm looking at dynamic capital regulation mainly. And I also analyze the performance of simple rules, the Basel rule in my framework. And I also differentiate between the returns on the asset side of two types of banks that is missing in the paper, for example, by Anual and Anual. Yeah, and my paper is also related to Basel III framework, and this is some examples of the papers. Just let me document some stylized facts, but before that, there is no unique definition of shadow banks. In general, these are institutions that perform bank-like functions but are not regulated as banks. And here I'm using a methodology proposed by Posar, and I mainly focus on the liquidity provision function of shadow banks. And these are the examples of institutions that I have in mind. The main idea that these institutions function outside the protective umbrella of public guarantees. And what are these three facts that I use when I construct my theoretical model and evaluate the performance of my theoretical model? The first one is that shadow banks' liabilities are more volatile than regulated bank liabilities. The second fact I think is interesting and rather new, that regulated banks expand relative to shadow banks in recessions, while regulated banks shrink relative to shadow banks in expansions. And I call this the reintermediation channel that is the key to the risk-taking incentives, additional risk-taking incentives that my framework gives me. And the third one is a link between financial conditions and also a relative expansion of one type to another. This is the roadmap to the framework of my models. So households derive utility from consumption C, and also deposits, two types of deposits are valued in this framework. There is an empirical evidence that shadow banks provide liquidity function to the economy. So I include shadow bank deposits into the utility function, like Anual and Anual paper. And households fund two types of banks, are regulated banks and as shadow banks with deposits and equity. And banks finance two types of firms. One is subject to only aggregate shocks. This is safe firms, I call them, but risky firms have technology that is also subject to idiosyncratic shock epsilon that follows a normal distribution with zero mean and variance tau squared. And just to understand what returns banks get, regulated banks, as I said, they have limited liability, so this is the maximum of their returns on portfolio. This is the safe return, RT plus 1L, minus a fraction of loans that goes to risky firms, times the exposure to the idiosyncratic shock, and this is minus the cost of deposits times the deposits. And I would like to capture the following fact that the social price of taking risk by regulated banks is higher than shadow banks because they have deposit insurance. And for that, I include an epsilon component, epsilon, or not epsilon, psi r component, and you can interpret it as that regulated banks incur cost to hide risky loans from regulators. And we have a standard balance sheet constraint, loans equal deposits plus equity. And this is the capital requirement, gamma, gamma fraction of loans must be kept in equity. There is no short selling constraint. It comes from the fact when banks invest into safe firms, then I do not allow that banks actually short sell risky loans. Otherwise, they will supply negative loans. And this is controlled by this inequality. And this is the minimum scale assumption that I'm using for my evaluation, for my estimation of the model and solution of the model, that the share of risky projects is between sigma smaller bar, sigma upper bar, but you can think about these boundaries are close to 0 and 1. So these assumptions are not binding. And for shadow banks, for those of you who are familiar with Götter and Karadi model, this is a market-based banks, so they do not face capital requirements. It's very similar. And we have, here I have that theta, this is the fraction of loans with which shadow banks can run away each period. So this is incentive compatibility constraint, something related to moral hazard. And other constraints are similar to the regulated banks. We also have capital producers, so they produce capital and supply it to firms. Firms pay for this capital, and we have government that uses supplies deposit insurance in case regulated banks fail. They impose a lump sum tax on households. I have a bunch of theoretical results, so just very quickly here, shadow banks choose for financing the maximum share of risky projects, and I also define the value of a bank as a linear function of loans and equity. The constraint is always binding here. This is incentive compatibility constraint, the same as in Götter and Karadi. The difference here is that since agents, households solve a portfolio allocation problem, equity is composed of two components, and the first component supplied by households is endogenous in this framework compared to what Götter and Karadi have in their framework. And regarding the regulated banks, the capital requirements always bind, and a bank optimally considers only two values for each choice of risk, either the maximum share of risky projects is taken or the minimum share in equilibrium. And the corollary is that three types of equilibria are possible. In the safe equilibrium, only safe projects are financed. In risky, only risky projects, and we have a mixture of equilibria when a certain share is financed, mu, risky and safe projects. Just some implications for bank optimization. I think that's the key for my mechanism to understand. So how should we think about what corner is chosen? Either the maximum or the minimum share of risky project is financed. And this comes from some standard forces, the first and second bullet point here, right, that have nothing to do with the presence of shadow banks. So we excessive risk-taking incentives rise when the returns on safe assets decrease, and we can interpret it as situations when banks search for yield, when safe returns are low. And it happens when the volatility of the returns, or standard deviation of risky returns increases, and this leads to the situation when limited liability becomes more attractive for regulated banks. What is new and what is the mechanism here? So it comes from the reintermediation of credit. I call it the reintermediation channel. So following negative shocks to portfolio returns, the competition of to the two types of banks increase the funding costs of loans, and this triggers the endogenous migration of loans and debt. So the idea is that equity returns of regulated banks are relatively less affected or fall less compared to shadow banks because regulated banks are less leveraged. And households rebalance their portfolios in order to equalize the expected returns on equity, and with binding capital requirements, in order to attract more debt, more deposits, they need to offer higher interest rates. And this high interest rates actually further decrease the returns on a loan portfolio, making the shield of limited liability more attractive. And this is the force actually that you will see later when I analyze the TFP shock. I studied the optimal RAMC policy, and this policy is conditional on the restrictions of the decentralized equilibrium. I define gamma star as the lowest capital requirement that keeps banks at the safe corner. And I also need to verify what happens when gamma goes to zero, so the benefits from liquidity are the highest, and I verify that gamma star is in fact the optimal value in my framework. And briefly about calibration, so I use a combination of calibration and estimation using the simulated method of moments on the US data. I use Z1 release of the flow of funds from 1990 Q1 to 2022 Q1. And there is a borderline that says that loans to firms with debt to EBITDA ratio greater than 6 raises supervisory concerns in the US. So in order to calibrate this tau R, this is the standard deviation of the risky projects, I associated with the risky firms with debt to EBITDA ratio equals 7, so a little bit higher than 6. And then conditional on this choice, I choose the value of this penalty on hiding risky projects in order to make the capital requirements equal is 8 at the steady state, which is the Basel III guidance and some what we can see from the period, calculate from the considered period. And it happens that the model is consistent with these stylized facts, so the moments are matched well. How do I evaluate the shadow banks, the impact of shadow banks in my framework? I actually compare the responses of optimal requirements under two cases when we have shadow banks and once we just abstract from them. And then I also consider how higher capital requirements affect the reallocation of credit, and then I do the analysis on Basel III guidance. So this is a summary of the response to two types of shocks, a TFP shock and capital quality shock. You see that the solid black line is steeper, meaning that there is in fact the magnification of the response of optimal capital requirements to a TFP shock. But when you look at the capital quality shock, the lines have different slopes, meaning that in case for the positive capital quality shock, the optimal response is to decrease capital requirement, but for when you take shadow banks into account, but abstracting from shadow banks, you increase capital requirements. And capital quality shock is associated with the efficiency of investment, and it is similar to Geltler and Karady framework. I think I've already discussed the TFP shock. This is actually the reintermediation channel that I mentioned before. What about the capital quality shock? Here there is a trade-off between, as usually in macro, between the wealth effect and, just very briefly summarizing. Let me just skip this and very briefly how we can implement different rules, Basel III rules in this framework. The idea is that Ramsey optimal policies place a huge restriction on informational restriction on policymakers. And here I just regress the Ramsey optimal requirements on the credit to GDP ratio and look at the coefficients for these regressions and find that the proposed rule that differentiates between two types of loans actually make all the coefficients significant, and I compare it against different statistical metrics, R squared, the consumption appeal variation, and you see that this rule is much better than the rule that only aggregates loans. And finally, just very briefly, what happens if I introduce a static buffer? And you see that the blue line is actually higher here than all other lines, meaning that static buffer is not enough for this economy to deal with excessive risk-taking incentives. But when we combine it with the rules shown here, you can actually decrease the losses coming from in terms of consumption associated with excessive risk-taking incentives of banks. This is a brief summary. I think I've discussed it. Thank you very much.
All right. It was. I really enjoyed reading your paper. It was really well written, and if you have a chance to read it, is You have some very clever ways of putting things in the paper. It's really nice to read. It's a really great paper in the sense that there's a lot going on. It's a big model, but everything in there has a purpose. And so it makes it really clear to kind of understand the mechanisms. And so I'm going to discuss the paper, and I'm going to throw in some comments in here and a few more comments at the end too. And so kind of what this is, you have this general equilibrium model, and you include shadow banks and regulated banks, of course, with households, governments. Kind of the key features, and I have asterisks here. These are the key features that I'm going to talk about. Are going to be households have preference for holding liquidity. There's endogenous risk taking, and there's going to be differential risk taking, or I'm sorry, differential regulation between shadow banks and regulated banks. And so the contributions, I would say, are threefold actually in this. And this is what I think is really, it's a really nice paper in this sense. The first thing is you write it to understand the data. Like this is what the data is saying. Draw a model to understand what the data is saying. Then you go into about policy. What are the optimal policies in here? Let's calculate the optimal policies. And this is in a quantitative model. And so this is like, can you really do this in practice? And so that's what you do third is, all right, let's just think about the real world. We're not exactly sure where some of the origin of these shocks are coming from. Are they coming from capital? Are they coming from TFP? So how would they do this in practice? Like what's a practical way that you could actually get closest to these optimal policies? And so you have the empirics, kind of this theoretical policies, and then how would you do this in practice? And one suggestion I would have is, after reading the whole paper, I was like, that's really cool how you put these together, is to 1 to 3 sentences say, I explain data, I show you kind of the theoretical, the optimal, and then in practice how to do this. Just to go through kind of the basic mechanism here is that these, the empirical facts are that these regulated banks, these liabilities grow in recessions relative to these shadow banks. And that means like a negative technology shock leads to the returns fall less in the regulated banks. And so what the equity migrates over to the regulated banks. But then there's binding capital requirements. The regulated banks want to attract these new deposits. And so they attract these new deposits by households have preferences to liquidity of these shadow and regulated banks. And they're not perfect substitutes. And so the bank has to entice them to make more deposits. You can see how this mechanism is going to work because it kind of amplifies the negative technology shock is going to, in the shadow banks, there's going to be a decrease in deposits, but then a lot of these are also going to migrate. So it magnifies these responses. And so you see that they're more volatile, these shadow bank deposits. You discussed, I think, pretty well about kind of this role of this regulation, but really, kind of the idea here is that I'm just thinking of a negative technology shock here, is that the role of regulation is that these firms, these regulated banks do have incentives to have more risky loans. And so this is where regulation can come in. And you put that into the model and have this optimal within the model. It's just that there's the different types of shocks though that can lead to regulation, right? You can have negative TFP shocks or positive TFP shocks, but you could also have capital quality shocks. And so the origin of the shocks is going to have a kind of a different, what is going to be the optimal policy? It's going to be different between these two. And so this is where you go into these proposals of, well, let's just try to think of how, if suppose a policymaker doesn't know where the origin of these shocks are coming from, how are they supposed to construct the optimal policy? They don't know what we know as the modeler. And this is where you come up with some simple rules, but very powerful. You can actually get really close to what the optimal is within doing different things in these rules. In that sense, I think it's very policy relevant, your model. But one thing about bringing this to policy relevance is to make sure that you've really nailed down the empirical fit on this. And I think you can, or at least you can see if it does. One other thing you can show in this model is that just the inclusion of the shadow banks in here, it changes kind of what's going to happen to the regulated banks. It's going to change the moments of the regulated banks just by the interactions between these two. In the paper you mentioned that these shadow banks, it's really 1990 is where this starts. And so what you could do, I think, would be really to show that this is, this model is bona fide in terms of explaining the data, is maybe go back to this flow of funds data, look pre-1990 when there's not as many shadow banks in there, then try to calculate, some of these moments within the regulated banks, whether these are the correlations between output and liabilities, volatility of liabilities, maybe some of those moments, and then redo the model, just shut off because you can do that. You have some experiments in there. Just shut off the shadow banks, see if these moments are matching kind of what the world looked like pre-1990, and if it is, that's pretty cool. Another thing, just to kind of highlight these mechanisms, and there's some of this in the appendix, not exactly what I'm thinking of, but just to try to see how these capital requirements are driving some of these results. I think it'd be cool if you could figure out how to do just static capital requirements and then run the model. And in this sense, you could think of, is the optimal being driven by changes in consumption or because of the value that you get from deposits? So I think that might be it. I have a couple others, but you didn't get into some of the more technical aspects, and so we can save these for after, just because you didn't discuss those as much. All right, thanks.
Thank you. Do we have any question from the floor? No? Maybe I have one question for you. In your model, you devise an environment where there is migration and reversal of credit from regulated banks to shadow banks. And this direction of this credit migration depends on the phase of the financial cycle, right? So could there be a role for the central bank as a lender of last resort that can buy and sell securities and thereby affect the spreads of corporate bonds and other securities issued by private banks, private sector, to address the inefficiencies from these interactions of shadow banks and regulated banks?
Yeah, thank you. Thank you for this question. Actually, what I'm doing here, I'm looking at some theoretical mechanism that I explore, and this is associated with the limited liability and deposit insurance, right? And capital requirements is the tool that is used here in order to correct the incentives of banks in order to shift from risky loans to safe assets. And I think that's a good comment. However, my framework, as it currently stands, is mainly about the role of capital requirements rather than liquidity provision function. But I think it can be addressed in a little bit different framework.
Okay, thank you.
Yeah, and regarding the chat's comments, I think, thank you. They were, I think, mainly suggestions rather than something that requires my response. So I'm looking forward to discuss them with you.
Well, if there isn't any more question or comments from the audience, so maybe we could please join me with an applause for all the participants and the presenters and the discussant. Thank you very much. And with this, we close our session.